In this video, we will learn about the reactions of alkyl halides. But before we talk about the reactions, we should recall the general structure of these compounds. This is the general structure of alkyl halides. And of course, as you remember, alkyl halides contain a carbon X bond. And as we learned before also, that the carbon X bond is a polar bond. The CX bond is a polar bond. So this is the polar bond that alkyl halides contain. The CX bond is polar, and the polarity of this chemical bond is due to the difference in electronegativity between carbon and X. Obviously, X is more electronegative than carbon, leaving carbon with a positive partial charge and X with a negative partial charge. X is a halogen. X could be fluorine, could be chlorine, bromine, a group 7A metal if you like. So X here is FClBrI in general. That's the general structure of alkyl halides. And this CX bond again is a polar bond, and that's because of the difference in electronegativity between carbon and X, and or if you like, because of inductive effect. X pulls electrons more toward itself in this chemical bond, leaving carbon with a positive partial charge and X with a negative partial charge. Because of the polarity of the CX bond, alkyl halides therefore are reactive, and their reactivity is manifested in two types of reactions in general. Alkyl halides can undergo two types of reactions. One is substitution and the other is elimination. So alkyl halides undergo substitution reactions if they react with a nucleophile. So they react with a nucleophile. Alkyl halides undergo substitution reactions. The nucleophile displaces X or the halide. The halide would then leave, so it's a displacement reaction also, or a substitution reaction. So the nucleophile displaces X, and this product is then obtained in general for the displacement reaction or the substitution reaction of alkyl halides upon reaction with a nucleophile. Of course, X has left, so we can also write here X minus. So a nucleophile reacts with an alkyl halide, displacement reaction takes place, or a substitution reaction takes place. This reaction is substitution or displacement. This is a substitution reaction, or sometimes it is termed as displacement. So it's a displacement reaction or a substitution reaction. That's when the alkyl halide reacts with a nucleophile. So that's one type of reactions that alkyl halides undergo. There's another type of reactions that alkyl halides undergo, and that is elimination. So alkyl halides can undergo elimination reactions, but this time the reagent that should be used is a base. So a base reacts with an alkyl halide in an elimination reaction to make an alkene in general. So this is the structure of the alkene in general, or the elimination reaction. The base, of course, will take off or abstract a proton from an adjacent carbon to the carbon that's bearing the X, which means from this carbon or that carbon. So these carbons, the adjacent carbons, sometimes called alpha carbons, you can label them as alpha. These alpha carbons must have a proton for the elimination reaction to take place. The base will take off a proton from an adjacent carbon or the alpha carbon to the carbon bearing the X, and then X will then leave. So this is what the base will do in this elimination reaction. So this is the elimination reaction of alkyl halides to make an alkene. So the alkene is the product of the elimination reaction. And please pay attention to the types of reagents used. A base is used in the elimination reaction, and nucleophile is used in the substitution reaction. Now, it's very, very important to recognize the difference between the base and the nucleophile. The base in general has an affinity for a proton. So the base is a substance. We can define it like this. It's a substance with an affinity for a proton. So this base has an affinity for a proton, yeah? And that proton has to be located on the alpha carbon. So this is how the base is defined, and this is what the base does. It removes or abstracts a proton from an adjacent carbon to the carbon that has the X. On the other hand, the nucleophile does not have an affinity for a proton. The nucleophile has an affinity for an electrophilic carbon. So this has an affinity for carbon. So that's the difference between the nucleophile and the base. The nucleophile is a substance, if you like, that is looking for an electrophilic carbon, or a substance that has an affinity for carbon. The base, as defined a while ago, has an affinity for a proton. So that's the difference with respect to the function or the role of these reagents between the base and the nucleophile.